Hello everyone, and welcome to today's webinar, Istio Traffic Management, Best Practices in Secure Kubernetes Environments. I am pleased to announce today's speaker, which is Christopher Liljenstolpe. He is the original architect behind Tigera's Project Calico. He speaks at over 60 meetups a year, educating people on networking and network security for modern applications. So before I hand the webinar over to Christopher, I have a few housekeeping items I'd like to cover on this presentation and the webinar platform. First off, today's webinar will be available on demand immediately after the live session concludes and will be accessible through the same link you used to get to this webinar. So we'd love to hear from you today. This is an interactive presentation. We love feedback and questions. So if you have a question to ask our speaker, please feel free to do so in the question area of the BrightTalk interface. And we will try to get to those questions on the slide that they are asked so that it is relevant. However, if we cannot get to your question, we do have a full Q&A session at the end where we can take any questions that didn't get covered or any new questions. So without further ado, let me hand it over to Christopher.
All right. Thank you, Michael. So if we take a look at the definition of what Istio is, Istio is a platform that delivers a concept called a service mesh. And there are other service mesh platforms that are out there. Istio, however, seems to have the most currency in the Kubernetes environment. So that's one we're going to be focusing on here. And it's actually the platform that we've decided to integrate with here at Tigera for both Project Calico, our open source, as well as our commercial offerings. But what is a service mesh? You'll hear people talking about asking that question. I ask that question at meetups, etc. When people are deploying service meshes or looking at service meshes and which ones you're looking at. But what do we mean by a service mesh? So if we think about the way we used to build applications, is we build a large monolith code base. And a lot of the functionality, or at least a lot of related functions, would be compiled together into one object or into one executable. As we have started going down the road, and we've been doing this for a while, of basically disaggregating those complex monolithic applications into functional components, what we end up with, so instead of now having a large monolithic piece of code, we now have a number of smaller executables that are running that each do some subset of the functions that one big piece of monolithic code did before. The reason we might do that is it's easier to maintain smaller pieces of code, easier to update smaller pieces of code. It forces a certain maturity around making sure there are clean abstraction layers between different functions. And also it means that we can reuse that code and reuse that module or the capability of that module for multiple applications. So we now have a disaggregated cloud of smaller components that are pieced together to deliver a specific service. This means that we've got a lot of network connectivity between these and a lot of message passing between them. So we now have said what we've now created is the necessity to build a network API substrate into your applications. Initially we did this, every developer, etc., wrote their own interfaces to all the different APIs and did all of the plumbing for all of this. This becomes harder and harder to manage as this disaggregated cloud gets larger and larger. So what is a service mesh? A service mesh describes exactly this. It describes that there's a network of microservices and the interaction between them. And indirectly, it means that we have to manage that interaction of microservices. What you need to do for this is there's a number of functional components that you need to do in a service mesh. You need to be able to discover the services. I need a service that provides me X. I need to find the thing or things that can provide X. if there are multiple instances of the thing that can provide X, I need to load balance between those, and I need to do that in such a way that I do get reasonable load spreading. I need to be able to handle failure recovery. If one of the instances providing X fails, I need to be able to recover from that failure and go talk to something else. Maybe another exact instance or something that has a slightly less capable version of X, etc. I need to figure out how to fail recover. I also need to get metrics and monitoring, what's actually going on in this fabric now. Operationally, there are other requirements. I need to be able to do things like A/B testing. I've deployed a new version. I want to test between the two versions, see which ones users like more, so I decided which one to go forward with. I need to be able to do Canary releases. I want to release a new version of my service into the wild and only have a small subset, maybe a pre-nominated subset of customers using it. It's called a Canary release, so I can see if it works and is bug-free before I go into general deployment with it. I need to be able to rate limit. I need to be able to make sure that a load on a specific microservice doesn't cause my whole environment to crash. I need to be able to provide access control, end-to-end encryption, other things. So all of these things and more you need to be able to do in a service mesh. Early generations, developers had to then, each time they wrote a microservice, had to keep all of these in mind and all these capabilities in mind. So if we think about it, really, certain microservice or a service mesh in a simple case would be just two microservices needing to communicate with one another. And again, this is what we need to be able to do, what we need to be able to handle, network timeouts. If all of a sudden there's A can't connect to B in a certain amount of time, what do we do? If A is clobbering B with requests such that B becomes unavailable, that's called circuit breaking and rate limiting as well. We need to be able to handle those. We also, again, like I said, need to be able to control some of the security characteristics. So this is sort of easy if my microservice graph, if my service mesh or my service graph is just 2 endpoints. And 3 endpoints, not that much more difficult, etc. But eventually you end up with this. You now have lots of microservices. Those microservices are components of different applications. So in this case, for example, you might have an application graph in order for one particular customer request is AGM and AGI. I calls to B. Another application service graph might be for another particular function, another particular request a customer might make or a user might make, might be AHP. So we now have this very large spider web worth of microservices. And now managing all those things we just talked about becomes much more interesting. And frankly, it becomes unmanageable. If we don't do something, what we end up with is some very substantial pathologies. What we end up with is, for example, some developers write their circuit breaking and back off mechanisms one way. Someone uses, say some developers use an exponential back off. If I can't connect to a service, I back off for a second. If I still can't, I back off for 2, then 4, then 8, then 16, then 32, ad infinitum. If the next thing down the line has a back off, maybe they do a linear back off, or a cliff back off, where they back off 5 seconds at a time, and then they go away and don't back off, don't retry again for minutes. I start putting a service together, a graph of these. I now have different characteristics at different points in the infrastructure. And we've seen folks who have things where you might have 15 minutes worth of back-off delay in a pathological case because every developer approached the problem a slightly different way. Same thing with circuit breaking, same thing with everything else. There's not a common view of how to do this within the organization because that code is embedded in each microservice. It's enough to make you scream. So, what does something like a service mesh like Istio provide you to be able to control this? And the concept behind a service mesh like Istio is one of the things it can do is traffic control. So this means that what you can actually do is you can define rules that are end-to-end across your estate of microservices. You can say, for example, for a given service, how the load balancing might take place. 90% of the traffic goes from microservice AV1 to BV1, but 10% goes from AV1 to BV2. You might be able to do things that are geographically based, such that, for example, if the request came in from Europe and was handled in a European front end, I'm going to make sure I send that request to the back end, also in a European data center, if at all possible, rather than sending it across the ocean. I might also route traffic based on device or browser, how somebody approached me, because I might send this to different rendering engines depending on that. Similar things for downtime upgrades and rollbacks. Provide standard mechanisms for things like circuit breaking, retry and back off, and failure handling. Basically what Istio environment does, or some of the other service mesh platforms that are out there, is gives you a standardized way of defining these behaviors and a standardized tool set. No longer do each of the developers have to write a circuit breaking algorithm or a retry and back off algorithm or a failure handling mechanism. All of that is handled by the service mesh infrastructure itself, in this case Istio. So the developers can get back to writing their functional code and rely on the underlying service mesh to take care of all of these housekeeping things that are basically better served if they are treated holistically and in a standard way across the organization. So let's talk a little bit about some of these. One example is end-to-end service control. If we go back to the graph from 2 spots ago that you would have seen, actually let's go back up to the graph two spots from now. You'll notice that, for example, A is a component of, is a provider to Microservice S, and it is a client of Microservice G and Microservice H. So it's actually part of probably 3 service graphs here. So if we go down now back to this point, what you really need to think about, this is what your users are interested in, is the behavior of the service they're buying, not the intermediate components of that service. So the fact that one application does A to H to P to Z, and another application makes use of S to A to G to V, the end user is interested in the result they get out of A, and therefore the flow from A to G or the flow from A to Z, A to Z, not the intermediate points. If the developers are writing all of this functionality in each component, you really can't get an end-to-end treatment of that, because each of these we're treating these as A to B, or A to H, and then B to D, or H to Papa to P, etc. And each of those are independent. What I really need is that end-to-end view, because that's what I really need to assure the customer, is that that whole application chain is developed or delivered as one coherent response that behaves correctly. So one of the things that you need to be able to do is do end-to-end service control. If you're implementing service mesh characteristics at each microservice, you do not get this end-to-end control. Whereas if I have a platform like Istio, I actually can have end-to-end visibility and end-to-end control over this. At the end of the day, I don't want my latency to be more than n milliseconds across this graph. If I've got a back-off happening between the ingress gateway and workload A, that's going to consume part of my latency that I really need from ingress gateway to egress gateway. So therefore, I might need to adjust for that in the workload A to workload B session I can't have that global view if I've only been treating the individual things. I'm instrumenting A independently of instrumenting B, independent of instrumenting the ingress gateway, etc. I need a holistic view of how this thing is behaving. So one of the things Istio does, Istio allows you to model your application rather than the individual microservices. It models it as a set of microservices, but you can then define what your end-to-end characteristics should be. So another one as part of this is service discovery and its related characteristic of load balancing. So in Istio, you define what a service is. You define all the service components. So in this case, service A and service B. The way Istio works is Istio injects a proxy into each pod that you want to be using Istio with, which is usually most of, or all of your application code. So there's now a proxy in there that actually handles the traffic between your microservices. And also, if you're using things like Istio ingress, etc., from your ingress into your services to begin with. So when a given pod, for example, offering service B comes up in the infrastructure, is spun up by Kubernetes load balancing or whatever else, that pod will register not only with Kubernetes, now it also registers with Istio. So now Istio maintains a full map of the service B endpoints. And those might be different versions of code. We'll talk about that in a little bit, etc. But the things that have been identified as offering service B. So when service A, now instead of the service A code itself understanding service discovery, service A just basically asks, it's for all intents and purposes, it's a local proxy to find it, to deliver traffic to service B. And that's entirely up to the proxies on both sides to make that happen. In that case, the proxy on service A will request the current list of things offering service B, and the Istio management processes, Mixer and some other things, are going to reply back saying, go talk to these services in this order, or only talk to this instance of this service, i.e. to enforce some kind of load balancing. So the Istio manager will take a look at who service A is, any of the metadata that might come along with it, and make a decision, or at least provide hints, depending on how things are done, as to which instance or instances of service B service A should try and connect to. And you start seeing how this then affects things like retries and backoffs and failure detection, is that Istio, now having sort of a global view, can steer different instances of service A to talk to different services of instance B and try and adhere to the overall specification you wrote for the overall service. In this case, it is made up of A and B. Some of the potential use cases of this capability are Canary deployments. So, if you think about it, you might roll out a new version of the code. Maybe this is a mobile application, and you've got a list of users in your beta application, either in Google Play or in Apple, in the Apple App Store. So you've got your list of beta users. And when you roll out this new version of the code, you want to try it on your beta users first. So you release a new version of Service B, like we said, it's called Service B Prime, and you tell Istio that that's only for users in your beta group. So the nice thing about this is the developer of Service A doesn't need to know about Canary deployments. And who knows, Service A may be the thing that gets Canaried next. So they basically should never have special code in those services to handle this use case. But now when Service A makes a request to Istio to connect through its proxy to connect to Service B, one of the pieces of metadata that you've told Istio is interesting is the user. So when that request comes in from Service A's proxy, Istio is going to look at it and say, oh, that user is in the beta list. So instead of directing you to service B, I'm going to direct you to service B prime. And therefore, the users in the beta list get your Canary deployment, get your new code, and everyone else continues to get your GA code. And no developer had to do anything. The person who defines the service had to make the change. Now, let's say your code isn't spectacular and you annoy a number of your beta users and they all go in and get off of your beta list. It's probably a bad outcome, but it's better than having all your customers do that. So the next time user Alice goes to your site, because they removed themselves from the beta list, the next time they make that request, and it goes through Service A presents the user to Istio. The Istio mixer, in this case, looks at it and says Alice is no longer in the beta list, so traffic to, Istio will send the traffic to the GA version of B, not B prime, and you now stop annoying Alice. So that's a little bit of a case of Canary deployments. And we have a question. So we have a question of, can Istio with RBAC, can that be used as an example? Basically, however you want to indicate that a given user, if you're using Istio RBAC as a mechanism to do identity, to decide if you should be getting to Canary deployments or not, that's fine. So you could be using Istio's RBAC, you could be using some other mechanism. However you are representing the users or authenticating the users in your system, because users wouldn't really be wouldn't necessarily be doing RBAC directly with Istio, but if there was, or applications may not. If they do, certainly you could do that. Otherwise, however else you are doing your RBAC for your application graph is fine. So now, if we think about, so for an example, there's another Canary deployment. So, I talked here about users on your beta list. You also might decide that you're going to subject randomly 5% of your users to the new service B prime. So in this case, Istio will keep track of the number of users, the number of requests that have been made, and will basically apply a randomization effort, if you want to think of it, and say it's going to take 5% of all requests and send that to B prime, and the rest go to A. And then one of the things which we're not going to talk about today, Istio gives you lots of visibility into use of your service graph. Even Istio could tell you to a certain degree how long those users stay engaged. You can look, is my service driving people away or holding them longer? Obviously, your application could also return some of that information. But this gives you an ability to see if your 5% deployment is working or not. Similarly, you might decide to use Canary deployments to put out a hot patch for a specific user client. You've got an issue. It's surfaced for a specific user client, say an iPhone. So I'm going to use something like a Canary deployment to say anything coming from an iPhone as a client gets pushed into my Canary B prime. Everyone else is still delivered to standard B. So that's a couple of Canary and Canary-like use cases. Another one which is similar is a dark launch. Let's say you're doing some form, especially useful when it's not interactive. So maybe you're deploying a new version of your analytical engine to your application. You could tell your service graph to replicate all the traffic that it's sending to your current GA version of your analytical engine, and also send that data to now your new test analytical engine. So this way you can actually launch off a new platform, and users would still be using the existing platform, but you're now getting real world use of your new version or your new service, and your users don't actually even know that that's going on. It's going on behind the scenes. The nice thing about all of these things is the application developer of Microservice A and Microservice B have absolutely no knowledge even that this is happening. There is no code in there that says, oh, I'm on this branch versus this branch, so I have to do this or that, or I need to, out of every 10 requests, I need to send one request to DNS entry of beta.service versus ga.service. None of that logic's in there. You don't need to build configuration options for any of that, etc. All of that's now pushed up into the service mesh layer. Go to the next one. So from a load balancing standpoint, again, you can use load balancing as a instance of, like I said, Canaries. We've covered that already. Other use cases, though, you could use, in this case, versioning. So that's a little bit like a Canary deployment, but you can also be used for something other than Canary deployment. You start off with a new version and you want to ramp it up. So it's not just, I want to send 5% there. I canaried it, it worked. So now over time, over the next couple of days, I keep on adjusting the ratio until everything is off my old version onto my new version. There's another use case, though, where you could say that I know that some of my nodes, or I know that some of my pods instances are lower throughput than others. In fact, Istio can help you figure that out. And Istio can say, this version of this deployment or these specific pods are slower or can handle less load than others. And Istio can do that because Istio is watching all the metrics of how fast all these services respond. Maybe that's because some of those pods are deployed on older version of your hardware and of your hardware fleet, and newer versions of the pod are deployed in newer versions, and you're not going to burn that old cluster down quite yet. So you can actually say, okay, the versions of the pods that are slower will get a total of 25% of my traffic, and the rest will get 75% of my traffic. And again, Istio can even automatically do that for you, do that load balancing for you, based on actual real-world behavior of these different pods, and will adjust as things adjust. So load balancing doesn't necessarily just have to be for things like Canary deployment. It can be because not everything is completely homogeneous in your infrastructure, and you need to be able to adjust for that. Another interesting case is, another interesting thing which I talked a bit about was circuit breaking in retry. So if I've got this service graph, service A, B, and C is what's delivering my service. And if each of my developers independently decided what their timeout is going to be, what their retry algorithm is going to be, how many times they're going to retry, what their backoffs are, etc., you can end up with some pathologies here. So if service A decides its timeout is, in this case, 9,000 milliseconds, for example, and service BC has a timeout of 3,000 seconds and a retry of, I said 2 here, but let's say 4 times, and a back off of doubling each time. Well, what you might actually get is service A to service B timeout, while service B, service C is still trying to make the request. And actually that request does eventually get fulfilled, but not before service A timed out. So then service A starts again, but it backed off again, and wash, rinse, repeat. And all of a sudden you end up with these pathologically long outcomes where actual latency across this is quite high. Sometimes things work, sometimes things don't. It all comes down to how the timing is set up between all of these services. In this case, it's sort of easy to fix this problem. A to B to C, you look across all of these and you set the numbers correctly and you're fine. But what if B is also connecting to service D because service X connects to B and is asking for something from service D, and service D has different timeouts. Service B has, still has the same timeouts whether it's A or D. All of a sudden, you now end up having to balance all of the settings, the timeouts, the retries, the backoffs, etc., independently for each service. So every time I add a new dependency in my service graph, I have to potentially reconfigure everything else in order to make sure that that everything still works. This becomes a very fragile, if not just completely broken model. The model in Istio is you can say, this is my end-to-end behavior I want. Here are the minimum or maximum characteristics that can be handled by each of the components. And then Istio will manage, because it controls the proxies, which controls the actual traffic between the microservices. Istio can then instrument and control, well, in this case, I need a timeout of no more than this in order to be able to meet the end-to-end goals. So managing this linearly looks simple. When you go back to the original graph that I had up there with the screen, this becomes impossible to do manually or on a to B basis. You really have to look at this from an A to Z basis. And the only way you're really going to do that is have something that provides sort of an overwatch across your entire infrastructure. So that's circuit breaking and retry. So if you think about, and we're going to talk about other Istio bits in the coming sessions, but in reality, you start thinking about, you need to be able to holistically look at things like circuit breaking and retries and backoffs in order to make sure you can deliver an end-to-end service your customers want. You need to be able to have different load balancing characteristics based on current behavior of systems, based on your needs to do Canary deployments or dark mirror deployments or dark launches. There's a number of in similar cases. Being able to do that in one place is really, really useful, and that's one of the big drivers for Istio. There are other drivers for Istio, but this is one of the big ones. This means that your developers can get back to writing this code that's important to service A, service B, service C, and not deal with the plumbing. So, why are we talking about this? You hear me harp on about security and core networking, etc. So why are we talking about this? One of the things that we have done in Tigera's solutions and in our open source solution is we have integrated with Istio from a security standpoint. We've talked about this before. We're going to talk about this again in an upcoming webinar. But the ability now to take your Kubernetes network policy and also apply it to the layer 7 characteristics that Istio looks at. So all the way up at the HTTP layer, enforcing encryption and doing filtering based on actual HTTP or gRPC objects. So this is why what we have done, we see Istio as being very important, not just from a security standpoint, but in general in deploying a microservice architecture, for the traffic management, for the visibility, which we're going to talk about as well, etc. So there's this tool of Istio is quite valuable in many aspects. That's why we think it's getting a lot of traction. So we can also then, because it's becoming a major player in this space, we have decided to extend our network policy up into Istio as well. So this is the intersection between Istio and Tigera at this point. And again, like I said, we'll be talking about this in a little bit later. So that is a little bit on Istio and Istio traffic management and why you should care and some of the things you can do with it. With that, I think I'm going to turn it back over to Michael and open it up for questions.
Thank you, Christopher. Before we get to questions, we'll give you a chance to type them in. We have an upcoming webinar in 2 weeks. In fact, we do a webinar every 2 weeks. So the next one coming up is on April 17th, and it is on securing Kubernetes applications on the Google Cloud. We will have more Istio webcasts coming up as well. You can also watch any of our past webinars through BrightTalk or at our website. And currently, we're highlighting a webinar we did with AWS on Atlassian. It's a case study on Atlassian and how they have moved securely to the cloud. And it's a really great webinar. There's some great information in there. The people from Atlassian are really on top of it, and it's a really great webinar if you really want to learn something about how a very popular application, massive user base, moves to the cloud. So securely. So with that, if we don't have any questions, which right now it seems like we have everybody on the webinar is an Istio expert and now ready for the advanced test.
Or they're asleep.
Yeah, well, you know, I'm in marketing, I can't tell the difference. So if we don't have any questions, which it doesn't look like we do, and we're not going to fool you with any seed questions that are fake, we'll just give you your time back.
But you're for marketing.
Yeah.
Don't you normally do that?
Yeah. Well, you know, hey, look, my job is just to present you, so that's all I'm going to do right now. So with that, thank you everyone for attending. We don't have any questions, so that's it. And we look forward to seeing you at our next webcast. By the way, copies of this presentation can be made available. One thing you can do is just reach out to, if you were invited to this webinar from Tigera's email, reply@tigera.io. If you reply to that saying, I want the presentation, or any other items you might have from us, questions, those will be routed to me, and I'll be able to get to those. We do have a question that came in. So, we have a bunch coming in now. Hold on a second here. Everybody sit back down, get comfortable. So we have a question here. Do you see Istio more for routing, or can it be used for security? I think you covered a little bit of that, but maybe.
So I think the answer is yes. We actually see three major use cases for Istio. We see one for security of the application flows themselves, and it's one of the advantages in Istio, and I'm sort of giving away a few of the things we're going to talk about later, is Istio can also do things like automatically drive mutual TLS authentication between microservices. It does that automatically. We can drive that, you know, with a finer grain of capability with our network policy in Istio. But Istio can make a determination, is a given microservice allowed to make a specific request of another microservice? i.e., is this thing only allowed to post to a given set of URIs, or is it also allowed to get from those URIs? It can also then, like I said, drive mutual TLS and therefore encryption of those flows as well. It can do, again, all of that without the developers having to specifically know that. So again, it allows you to abstract that away, that plumbing away from the developers. It also means that things like Heartbleed no longer require you to refactor every single application in your infrastructure, because the actual encryption is being done by the Istio proxy, which is an Envoy actually right now, in every pod. So you just need to update Istio's proxy with the now new version of OpenSSL or whatever that is not Heartbleed 5 vulnerable, and you're secure again. So it sort of moves a lot of that crypto plumbing and making sure that everyone's using the right versions and doing the policy enforcement on the layer 7 flows. That's all the security capabilities. Use case 2 that we see at a high level for Istio is visibility. Being able to see how your different microservices perform, what different versions perform better than others, what geographies, how your APIs are performing in general, where your bottlenecks are, where are you taking a really long time to make a response in an overall app. And if this application, everyone loves it. This application is slow. My customer web order form is slow. And why is that? Well, if I can actually see that entire service chain, the 20 microservices that are involved in painting that order form, I can see all the traffic between all those 20 microservices. I can see where the latencies are, et cetera, and I can maybe go fix it. So visibility, really important as well. And then your question, routing or traffic management, similarly very important. The nice thing about all of these things is they're inherent in Istio. I don't need to go build them into each of my microservices and have each developer do it slightly differently. You know, I hate to blag off on developers. I love them greatly. But if you have 15 developers developing 15 different microservices, you will have 18 different ways of doing back off and 22 different ways of doing visibility, etc. So having this done one way is useful. What becomes even more useful, though, is how these things get put together based on the visibility of the latency of these APIs, the load balancing immediately gets automatically adjusted. Based on visibility of flows, you could use anomaly detection and use that to change your security posture. And so all of these things, not only independently, are quite valuable, when you start putting them together is where you get some incredible value out of this. So I think different people come to Istio for different reasons. Very often it's the traffic management is the thing that drives people originally to Istio, but once you get to and sometimes it's the visibility, and sometimes it's the security. But once you see these, they all sort of play together and give you one whole that is certainly greater than the sum of its parts. Do you use Istio for DevOps? Certainly you do. Let's think about a DevOps cycle. Now, for example, you can say, my test traffic should be, only receiving my test microservice should only receive traffic from my testing harness. When I want to promote it to production, as an example, I don't need to change anything in the code. I just change the routing rules in Istio, say now I want all the traffic to go to prod. I want to be able to receive traffic from the prod workloads, now be steered to this new instance versus being steered to the previous instance. I don't need to change anything in the code, which means you can actually test and evaluate the code and the configuration you're actually going to deploy. You're only going to make shifts potentially in Istio. Other things where you can do is from a DevOps perspective, you can actually watch the behavior and performance of your APIs. So now in real time or close to real time, how your APIs are performing can feed back into your sprints, and you can say, okay, well, we made this change and our API latency just went up by 40 milliseconds. Can we fix that? Versus discovering that way at the end of the test cycle. Next. Okay. Istio is production ready. Istio is production ready. We are seeing people deploying Istio in production. So yes. Can Istio handle pod security policies? Istio init container needs to run with admin privileges. Is there an alternate to this called CNI plugin? So I think this, first of all, Istio and CNI plugin are different things. So the CNI plugin is what is providing, the CNI provider is something like Calico, etc., provides the underlying network, the layer 3, layer 4 network that is necessary to support pod-to-pod communications in general, let alone pod-to-pod communications with Istio. So you could do network policy within Istio. However, that means that all traffic, including non-layer 7 traffic or non-HTTP traffic, would have to go through userland proxy. That is a bit of a performance issue. So that's one problem. Another issue is that means that all policy is being forced within the pod. If the pod becomes compromised, if the pod becomes compromised, you lose all ability to control that pod, both ingress and egress. If you take a look at a number of the implementations of Kubernetes network policy, like Calico, a lot of those are enforced outside of the pod boundary in the underlying host. So if you take this concept of zero trust, for example, you can use Istio to provide control at layer 5 through 7 within the pod, and you can use Kubernetes network policy to control outside of the pod in the host namespace. And one of the things that we've done in Project Calico and in Tigera's solution is we've extended network policy to allow you to have one object that drives both Istio security policy and Kubernetes or Kubernetes network policy API policies off of one single object. Versioning and what if. So another question of versioning and what if changes to Istio routing rules. And there's a couple other questions here, like discussed in zero trust and intrusion detection. I don't quite understand what those questions. Okay. So the first question is versioning and what if changes to Istio policy rules. So I think what the questioner here is can you do what ifs? And that's sort of the whole idea behind a Canary deployment. You can have a small percentage of your traffic, if you have a what if question, you can have a small percentage of your traffic and filter it off to your what if scenario, your new version of whatever. Or I want to route this through this other microservice that I wasn't routing it through before first, maybe a machine learning jig or something along those lines. Or you could even do a dark launch. And that allows you to do a what if. If it doesn't work, you just flip that off, set that balance down to 0%, and you've failed back to known good working. In previous session we discussed permission-based routing. A can talk to B and C, but C only listens to A, as better than firewall rules. Can you add to that? So again, if I think about it, I have two parties that need to agree that a communication should happen. So let's say I've got three microservices, Alpha, Bravo, and Charlie. The developer for Alpha, believes that it should be able to talk to Bravo and Charlie. But the developer of Charlie believes that it should only be able to receive traffic from Alpha. So this could be a use case where the developer of A is writing a front end and he thinks he should be able to talk to multiple backends. But another developer thinks that only, say, PCI-enabled front end should be able to talk to my particular service because my service is PCI contaminated. So in that case, even though A has said it should be able to talk to B and to B and C, and the question here was only C should be able to listen to A. More importantly, B is saying, because B is PCI contaminated, that it should not be allowed to be connected to by A, because even though it's a backend, it is PCI contaminated and A is not PCI authorized. So in that case, we have a mismatch in the graph. If we just relied on A's rules, then A would be able to talk to B, which would be a PCI violation. So both sides of a communication need to be able to communicate. This isn't just an Istio thing. This can be enforced partially in Istio, partially in network policy, or all in network policy, or all in Istio. But in a zero trust environment or a least privilege environment, both sides of the communication need to be able to agree that communication should be allowed. So yes, you can do this better than with a classical single point firewall. You can distribute this and you can make this enforcement happen at multiple points. And I'm not quite sure, there's a question here that says intrusion detection, but that's about it. So I hope I answered that to a certain point.
Okay, great. Well, hey, listen, everyone, thank you so much for all your questions. I knew you had it in you. Very proud of you all. And so with that, we are going to conclude today's webinar, and we will see you next time. So Christopher, thank you, and thank you everyone for attending.